Hello everyone, welcome to Chemical Engineering. I'm Parma.
And I'm Leonie, and we'll be presenting our chemical engineering and honors degree to you today. What is chemical engineering? In chemical engineering, we work on the conversion of raw materials using a variety of processes to form products that the society needs. This includes studying the properties of the raw materials, designing new equipment, and also controlling the processes to form the final products at large scale. Therefore, chemical engineering is sometimes also called process engineering.
When you study chemical engineering, you study in three broad categories. The first one I call the foundations. These are the really critical enabling subjects that allow us to build on and learn chemical engineering. These subjects include mathematics, physics, chemistry, material science, and fluid mechanics. Then you move on to the more core subjects in chemical engineering, which are reaction engineering, mass and energy balance, thermodynamics, process engineering, process control, and separation processes. Then you move on to the more advanced unit in the final year, the chemical engineering design project and the chemical engineering research project, where you apply all the knowledge that you have gathered from your foundation units and core units to solve real-life challenges.
The first chance to study chemical engineering is in the first year elective unit, Grand Challenges in Chemical Engineering. In this unit, we focus on delivering sustainable food, water, and energy. These are considered the grand challenges for a sustainable future. We will look into plant protein processing, batteries, biofuels, and water separation membranes for producing clean water for all around the world. Now we will look at what jobs and careers await me if I study chemical engineering. So the first example is the pharmaceutical industry. This is a $20 billion industry in Australia, of which as much as $10 billion is located in Victoria. This is the second largest export product of Australia. And of course, it's involved in the biotechnology and drug development. Second industry that's very large for chemical engineers to work is in food process engineering. And especially in Victoria, there is a huge dairy industry. Other opportunities are in nanotechnology, and Parama will follow up with some further examples of industries where chemical engineers typically work.
As a chemical engineer, you may like to join the traditional oil and gas sector or to more emerging sectors like renewable energies, which is worth $1 trillion. You may also like to have an exciting career in wastewater treatment or development of batteries for electric vehicles or grid storage. You may be developing next-generation fuels like biofuels, or may be involved in production of materials, systems, and processes. You may also have, as a chemical engineer, an exciting and important career in the emerging area of sustainable recycling of waste and recovery of materials. Half of chemical engineering students pursue double degrees. Double degrees allow you to enroll in 2 degrees at the same time in 2 completely different disciplines. Organizations often seek graduates with expertise in other disciplines. They continually praise the breadth of knowledge and insight our chemical engineering double degree students have. Double degree allows you to pursue careers in 2 different areas, or you may be able to take up an opportunity arising at the intersection of these disciplines. Chemical engineering double degree allows you diversity, great career choices, and flexibility with just 1 extra year of study. As a double degree chemical engineering student, you get to participate in exciting student societies. For example, the Monash Engineering and Pharmaceutical Science Society. These societies provide students help and support in the academic, industry, and personal areas. You also get to be a part of exciting student teams, and these teams include Monash Solar Water, Monash Fuels from Waste, CarbonX, and Monash Brew Lab. These teams develop commercially viable technologies to address real-world challenges. For example, the Monash Solar Water developed technologies based on solar steam generation, which can provide clean water to thousands of communities around the world.
So Monash Brew Lab is another team that's very active here on campus in our food grade lab. They work on a nano brewery for the production of beer and kombucha using innovative engineering and design, as well as sensoring to monitor the process. The Monash Fuel from Waste team takes food waste from all around campus to convert this into biofuels using yeast. This contributes to the circular economy here on campus and develops the technology to implement this outside, as we've just seen the opening of a waste-to-fuel plant in Victoria. Then lastly, we have also the Society of Monash University Chemical Engineers, or SMOOS, which is our core undergraduate student group that creates a link between students, academics, and the industry to ensure that our students are ready to get into their careers in industry or academia, and also to ensure their professional and personal development during the degree. So on this last slide here, you can see our graduates from 2019 together with all the academics when they just finished their final capstone design project. You can be part of this, and you can join us for sustainable chemical engineering at Monash to solve the world's most important challenges of this century.
Hope to see you all in chemical engineering. Thank you.